Welcome back, everybody. Today we are going to be looking at lesson 9-6, and 9-6 is on trapezoids and kites. This is our last lesson that's going to be introducing new shapes, and then we are going to be using them. So that will be the last lesson of the unit. So let's go ahead and go to our notebook and we'll get started. So in the last lesson, I had forgotten to have you put this infographic in, and it's just a really concise way to look at all of the properties of rectangle, rhombi, and squares. So we'll go ahead and start by putting this one in, even though this was really from the last lesson, because I forgot to have you put it in. And it's a really nice list of all of the properties that goes along with it too. Okay, so we are going to start lesson 9-6, which is on trapezoids and kites. So let's start with the definitions. The definition of a trapezoid is a quadrilateral with exactly one set of parallel sides. So this is not a parallelogram because it doesn't have two sets of parallel sides. It only has one set of parallel sides. And I'm sure you guys all know what a trapezoid looks like, right? So this side would be parallel to this side. And that is the only criteria that we need for a trapezoid. Nothing else has to be proven for it to be a trapezoid. So let's talk about the parts of a trapezoid. So first of all, this side and this side are called the bases. So there are two bases on a trapezoid. And then this side over here and this side over here are called the legs, or the legs of a trapezoid. That is, these are vocab terms, by the way, so we'll go ahead and highlight them while we're at it. And then an angle that touches the base and one of the legs, so this angle here and this angle here, are called base angles. The top ones could also become base angles as well. And so base angles of a trapezoid are also a vocab term. So those are just definitions because of where they are. Now, there is, so we have trapezoids that might look like this. You have trapezoids that might look like this. And it doesn't matter what they look like as long as you have that one set of parallel sides. Now, there is a special kind of trapezoid, and the special kind of trapezoid comes directly from a isosceles triangle. So if we were to come in here and we were to cut the base or cut this top part off of this isosceles triangle, this would create a parallelogram. I'm sorry, not a parallelogram, a trapezoid. That would create a trapezoid. That trapezoid that is created from an isosceles triangle still has one set of parallel sides, but it also has one set of opposite sides congruent. This is called an isosceles trapezoid. And the definition of an isosceles trapezoid is a trapezoid with congruent legs. A trapezoid with congruent legs. Then it becomes an isosceles trapezoid, and that is also a vocabulary term. So let's talk about the properties of a trapezoid. So the first property of a trapezoid is, or these, I'm sorry, properties of isosceles trapezoids specifically. These are not just trapezoids, of isosceles trapezoids. So it says that each pair of base angles is congruent So if this is our isosceles trapezoid, that angle is congruent to that angle, and that angle is congruent to that angle. The second property then is its converse. So if a trapezoid has one pair
Miss Colmia,
yes,
are you doing tutoring?
Miss Hall usually does tutoring on Wednesday mornings.
Say that again.
Miss Hall usually does Wednesday mornings.
Okay.
If she's
I'll
not,
check with her.
if
Thank
she's not
you.
here, send them down. But
Okay, does she do it in your classroom?
no, she does it in the library.
Oh, okay. Thank you.
You're welcome. If a trapezoid has one pair of congruent base angles, then it is an isosceles trapezoid. The third one is a trapezoid is isosceles if and only if. So there's a biconditional. Remember, by biconditionals, we can flip-flop back and forth. So we can use its converse and we know its converse is true. If and only if its diagonals are congruent. So it can only be an isosceles trapezoid if the diagonals are congruent. So that one has to be congruent to that one. And those are the properties of an isosceles trapezoid. So we're going to start with 1, 2, 3, and 4. In our guided notes. Okay, and we're going to show that OSRT is a trapezoid. So to show it's a trapezoid, we have to show that there is one congruent set of parallel sides. So all we really need to do is find the slopes and make sure that the slopes are parallel. So it looks like we're rising 2, running 4. So that would be 4, I'm sorry, rising 2, running 4 would be 1/2. And this would be rising 1, running 2. And so that is also 1/2. So we can show that it is a trapezoid because slopes of opposite of one set of opposite sides are both 1/2. So which interior angles of ORST, so this guy up here, are supplementary? So this is not a parallelogram, so we can't show that they are supplementary. But we do know that if this is parallel to this, we can pretend that this guy's a transversal, and we can pretend that this guy's a transversal. And if that is true, then this angle and this angle are consecutive interior. This angle and this angle are consecutive interior. So therefore, we know that angle R and angle O are supplementary. We also know that angle S and angle T are supplementary because they're corresponding, alternate interior, consecutive interior. Yeah, that's what I meant. Okay, we're going to determine if the quadrilateral is a trapezoid. It is a trapezoid, and these have to be parallel because both of these are right angles. So this is by perpendicular transversal theorem. So yes, it is a trapezoid because of perpendicular transversal theorem. Okay, so the next thing that we are going to, let's see, these two are on specifically isosceles trapezoids. So let's look at these. So we're going to find the measure of angle L, angle J, and angle M, assuming that this is a trapezoid. So if this is a trapezoid and we know that angle K is 50, we know that base angles are congruent. So we know that measure of angle L has to be 50. And we know that these guys are going to be supplementary. So if that's 50, then the measure of angle J and the measure of angle M, because they have to be congruent because they're base angles as well, then have to be supplementary to the 50, which means they are both 130 degrees. And then the last one, if EG, so diagonal, is equal to FG, or FH, sorry, is trapezoid isosceles? Yes, it is isosceles because one of the properties of an isosceles triangle is that its diagonals are congruent. Okay, so the next thing that we're going to talk about is a mid segment of a trapezoid. So something that kind of cool happens when you have isosceles trapezoids. So mid segment of a trapezoid is a segment that connects the midpoints of the legs of a trapezoid. So what I mean by that is if you have a trapezoid and this is the midpoint and this is the midpoint, it's a segment that connects them. And the really interesting thing about mid segments of a trapezoid is that if you have a mid segment, its lengths are the mean or the average of the two bases. And this always happens. So we're going to look at these next. So in the diagram, MN is the midsegment of trapezoid PQRS. Find MN. So just like I said, if you have a midsegment, its length are the average of the two bases. So we find averages by adding two things together and dividing by the number of numbers. So if we add 10 plus 18 together, we get 28. And we're going to divide by the number of numbers, which is 2. So this has to be 14. And same thing here, if we have 12 and 28, we add them together and we get 40. And we divide it by the number of numbers, which is 2. So the mid segment must be 20 inches. So pretty cut and dry, easy peasy for mid segments of a trapezoid. If they give you the mid segments of a trapezoid and 1, you could write yourself a formula. So let's pretend that we are given a mid segment of 20 inches and a base of 14 inches. Well, in this case, we don't know the other base. So we would just be adding 14 plus X. So we're going to add the bases and divide by 2. And we know that that would equal 20. So now that we have that equation, remember, plug in what you know, solve for what you don't know. You could find the other base by doing it that way. All right. So the next part we're going to talk about is kites. And by definition, a kite is a quadrilateral with exactly 2 pairs of consecutive So side by side, congruent sides. This is not a parallelogram. Also, the opposite sides of a kite are not congruent nor parallel. If they are congruent or parallel, they would be a rhombus, not a kite. So just like the kite that you go out and fly, by definition, it's a quadrilateral with exactly two pairs of consecutive congruent sides. Okay, and the properties of a kite, diagonals are perpendicular. And exactly one pair of opposite angles are congruent. And that will always be this one and this one. So it's always the one that is in between. It's always the included angle between the two sides that you're looking at. And we know that diagonals are perpendicular. It doesn't tell you this, but also a third one is that diagonals are angle bisectors. That occurs in every kite as well. Okay, so we are going to add our algebra problems in here. So if the measures of the angles of a kite are 3x, 75, 90, and 120, find the value of x. Well, it doesn't matter which ones these are in because we know that a kite is a quadrilateral. And if a kite is a quadrilateral, we know that it has to equal 360. So we could just say that 3x plus 75 plus 90 plus 120 has to equal 360 because it is a quadrilateral. So if I add those together, 75 plus 90 plus 120, we get 3x plus 285 equals 360. And subtract 285 from 360. We get 3x equals 75. So x has to equal 25. And then on this one, it says find the measure of angle D and the measure of angle A. Well, we know that these two, because they are the included angle between the sets of sides, we know that those are congruent. So angle D has to equal 120 degrees. And then if we have 120 and 120 and 50, that would be 240 plus 50, which is 290 minus 360. We know that the measure of angle A then has to equal 70 degrees because a quadrilateral has 360 degrees. And number 3, find the side lengths of, oh wait, this is not right. I am so sorry. Diagonals are not angle bisectors. Find the side lengths of the kite. So since we know that these cross at a 90-degree angle, we can use some Pythagorean theorem here to find the sides. So Wx is going to equal Wz, and we know that xy is going to equal zy. And so if we have 4 squared plus 6 squared, that gives us 16 plus 36. And 16 plus 36 is 52. So the square root of 52 simplifies to 2 root 13. And we know that those are congruent. And then our other one is 6 squared plus 12 squared. So that would be 36 plus 144 is 180. And the square root of 180 simplifies to 6 root 5. And I'm going to leave this proof for in class, but we are going to put it in to our notebook. Now, one final thing for this lesson. In your notes packet, you should have a piece of paper that looks like this. And this is a guide to classifying quadrilaterals. And all you have to go through this guide is go through and read and answer the questions, and it will help you classify the quadrilateral. Now, we always give the most specific name. So for example, if I have a square, I don't call it a rectangle because a rectangle is less specific than a square because a square is not only a rectangle, but it's also a rhombus. If I have a rectangle, I don't call it a parallelogram. I call it a rectangle because it's more specific than a parallelogram. So this is just to help you go through and classify quadrilaterals. So that is all for lesson 9-6. I hope that you picked up everything. If you didn't and you want some more work and some more practice, come and see me. I'd be more than happy to work with you some more. So until next time, we'll see you later.